Welcome to this explainer. I am absolutely thrilled you're here. Now, this explainer is brought to you by Forge College, and today, well, we're grabbing our magnifying glasses and putting on our detective hats. If you've been following along with our migration track, you know that moving your smart contracts from Ethereum to Solana is, well, it's quite the journey. In our previous lesson, we ported Hardhat tests to Anchor. But what actually happens when you've migrated your tests and things just break? Today, we are mastering the art of debugging Solana programs. We're going to give you the exact detective's blueprint you need to solve those incredibly frustrating runtime bugs. Okay, let's take a quick look at our agenda for today. First, the post-porting bug blues. Then, your new debugging toolkit, followed by a step-by-step bug investigation. After that, we'll translate symptoms to fixes, put together the final debug report, and finish up with wrapping up and CI. All right, Section 1. The post-porting bug blues, the scene of the crime.
So, you just ported your Hardhat test to Anchor, you translated your fixtures, you hit run, and bam. You were probably greeted by an incredibly intimidating red wall of failing test. Honestly, it's completely normal. So you're probably asking yourself right now, why did my ported test fail? Well, when you translate a test from EVM to SVM, a failing assertion usually points to one of two things. It's either a really simple translation error, like forgetting to include a signer or an account address, or, and this is way more common, you've run straight into a Solana-specific runtime condition that you simply didn't have to worry about back on Ethereum.
To really wrap your head around this, think of the EVM as the chill roommate. It handles state management totally automatically for you. Need a new account? The EVM just implicitly creates it. No stress at all. But the SVM? Oh, the SVM is the strict bureaucrat. It demands exact paperwork. You literally have to explicitly allocate space in bytes. You must ensure the account's rent exempt by funding it properly, and you have to follow these incredibly strict account ownership rules. If you forget to file any of this paperwork in your translated test, the SVM doesn't care. It will immediately reject your transaction. Moving right along to Section 2, your new debugging toolkit. Consider this your lab equipment for the SVM. Now, to deal with the strict rules of the SVM, you really can't just rely on console logs from your test runner anymore. We need specialized lab equipment. Tool number 1 is the solana-test-validator. Think of this as your completely sterile laboratory. It's a local test environment running right on your machine that gives you predictable, isolated execution. And why is this absolutely crucial? Well, because if you test against a public DevNet, your logs get completely buried in everyone else's network activity. It's a mess. By running the local validator, you guarantee that the only logs you see are the exact ones generated by your specific test. Okay, tool number 2 is simulate transaction. This is an amazingly powerful off-chain RPC method. You see, often, a failing test aborts long before a transaction is ever confirmed on-chain, effectively leaving you flying blind. Simulation allows you to take that exact failing payload and dry run it. It returns the runtime logs and traces the entire execution path without actually mutating any on-chain state. It is simply the perfect way to safely inspect exactly what went wrong under the hood. And that brings us to tool number 3, the MSG macro. This is a neat little Rust macro that you drop directly into your Solana program's code. If those first 2 tools are your magnifying glass, the MSG macro is basically like planting tiny hidden microphones inside your smart contract. When the program executes, these microphones broadcast the internal state, the variable values, and the exact moments right before panic happens, straight over to your validator logs. It's a real game changer. All right, let's hit Section 3, step-by-step bug investigation, the standard operating procedure. Now, what's really interesting about this slide is that having tools is great, but having a standard operating procedure is what actually makes you a true detective. We're going to follow a strict, repeatable workflow to dismantle these bugs. Think of this as your rapid feedback loop. Step 1, reproduce the failure reliably and capture the transaction signature. Step 2, use simulate transaction via RPC to safely extract those error logs. Step 3, inspect those logs, and if the root cause isn't completely glaringly obvious, go ahead and add targeted MSG traces into your Rust code and rebuild. Step 4, iterate on your hypothesis, apply the fix, and validate that the test now passes. You literally just loop through these 4 steps until that bug is squashed. But wait, before you start looping, you absolutely have to remember this golden rule. Keep the reproducer minimal. Seriously, if your test executes 10 instructions across 15 different accounts, finding the bug is like finding a needle in a giant haystack. Instead, isolate the failure down to a single instruction and a single account. The smaller the test, the faster your diagnostic loop will be, and the much quicker you can confidently confirm your fix. Section 4, already, translating symptoms to fixes. Let's decode that red text. And this brilliantly illustrates exactly what to look for. Now that you have your isolated logs, you're going to see specific error strings. This is where we match the fingerprint evidence left at the scene to our usual suspects. Here are the most common symptoms you're going to encounter right after porting from EVM. If you see account not initialized or account data too small, your initial hypothesis should immediately be, oops, I forgot the paperwork. Double-check that you explicitly allocated space and funded it for rent exemption. Now, if you see incorrect program ID, you likely passed an account to a cross-program invocation that is actually owned by the wrong program. And if you get signature verification failed, it almost always means you just forgot to include a required signer in your test's instruction builder.
Keep this cheat sheet handy, for sure.
Moving to Section 5, the final debug report, filing the police report. So you've investigated, found the bug, and fixed the code. Are we done? Absolutely not. A good detective always files their paperwork, right? We need to document this investigation so the issue is completely reproducible for your teammates and, of course, for your automated systems. You should create a really simple markdown file. Let's call it debug_report.md. Make sure it's precise. Include a one-line title of the failure. List the exact commands to reproduce it. Attach your captured artifacts, like the transaction signature and the simulation log files. Write a short root cause analysis mapping the logs directly to the bug. Show the specific code snippet you changed to fix it. And finally, paste the terminal output showing the test validating as a pass. Now, I know it sounds like a lot, but this isn't busy work. This is exactly what you attach to your team's issue tracker so everyone learns from the fix. I want to leave you with a quote that should really drive your entire workflow. Always prefer deterministic, minimal, reproducible tests. Combine client-side simulation with program-side traces. Honestly, remembering these two practical principles will fundamentally transform and improve your Anchor debugging. And finally, Section 6, wrapping up and CI, closing the case. Okay, so we've investigated the scene, found the bug, fixed the code, and filed a report. We are officially closing the case on this specific bug. But the overall journey doesn't stop here. Next up in our migration track, we'll be tackling continuous integration for Anchor test suites. And why does that matter right now? Well, because those debug reports and log artifacts you just learned how to create, they are the exact inputs required for your CI pipelines. We're going to wire up your local validator runs so that these regressions are caught entirely automatically on every future pull request. So the crucial point here is that you internalize this quick recap checklist whenever you face a failing migrated test. Number 1, reproduce it reliably. Number 2, capture that signature and run a simulation. Number 3, use our cheat sheet to form a hypothesis from the red text. Number 4, plant your MSG, microphones if you need more visibility. And number 5, commit the absolute smallest code fix that turns that red text green. So my final question to you is, are you ready to close your open cases? Armed with this blueprint, those strict SVM rules shouldn't be intimidating anymore. Really, they're just a new set of clues waiting to be solved. If you want to dive deeper into testing, debugging, and mastering the Web3 development workflow, be sure to visit forge.college. We have some incredibly comprehensive resources to guide you through every single step of this ecosystem. Thank you so much for joining me on this Explainer by Forge College. Keep iterating, keep debugging, and I will see you in the next one.